Hey guys, did you know the energy that we use today is billions of years old? And it's still the same energy that was around from the Big Bang, every single bit of it. It all started 13.8 billion years ago. That's when all of the energy in the universe came from. In fact, every element on the periodic table came from that Big Bang, and we're using it over and over again. As you'll see in science, pretty much everything's just cycles going round and round. The crazy part, actually, is that we're made of atoms. We're made of atoms that were made during the Big Bang. And those atoms, when we die, will just go on and on and on forever and ever and ever. Pretty cool. In today's lesson, we're going to be looking at energy stores and energy transfers. We'll be looking at all of the different types of energy store that exist, how energy is transferred, and also the key term that examiners are always looking for, dissipated, what it means and how to apply it. So we're going to go through all of the energy stores today, all of them being chemical, thermal, kinetic, gravitational, elastic, nuclear, electrostatic, and electromagnetic. Firstly, though, thinking of those, keeping those in mind, if I take a match here and I light it, what kind of energy store is this? I bet you're thinking thermal because there's heat, but actually this is chemical. It's chemical because we have two chemicals in the match head, and those chemicals reacted together when kinetic energy was applied and they converted to something else. We can show that if we look at a normal match and a burnt match. They're very different, aren't they? Whenever there's a change in physical appearance, and there's an obvious change here, and something's happened, energy's been released, then it's going to be a chemical energy store. That chemical energy store transferred to thermal energy. So keep that in mind. The next energy store we'll have a look at is kinetic. If we look at my car on the board here, if I release it, the car moves. That's kinetic energy. But what's happening when it crashed into the box? When it crashes, that kinetic energy has been transferred. Just think about when you rub your hands together. We've got friction there. Whenever there's friction, there's heat energy. So kinetic energy is one of those that naturally transfers into thermal energy. If we were to look at an elastic band and I were to stretch an elastic band at you, I would be using mechanical energy from myself. I'd be putting kinetic energy into the elastic band. Then I'd release it. That elastic band would convert to kinetic energy. It would fly across the room and it would hit the ground, and a tiny amount of thermal energy would be transferred to the surroundings. So let's have a look then at all the energy stores and the examples of them. If I share my board, you'll be able to see that. So firstly, we've got chemical energy. We can have chemical energy stores. Now, we've already looked at the match, which is an example of chemical energy. Anything that's on fire, which is changing form from one thing to another, is a good example of a chemical energy store. So for this, let's just put our match. The next one, as you can see, is thermal. Now, this one we often kind of mix up, don't we? Just like I said at the beginning. Now, the thermal energy store is something that's releasing heat. And an example of that could be a hot water bottle, a hot bath, anything like that. Now, as we're talking about this, it's like the hot bath. If you run a bath and you leave it for 20 minutes or an hour, you'll feel that the water's got cold. That is because the energy's been dissipated. It's been lost to its surroundings and it's no longer in a usable energy store. That's what we mean by the term dissipated. Kinetic. Now, kinetic can be anything that's moving. Kinetic just means movement energy. So for this one, I'm just going to say a moving car. A moving car. Then we've got gravitational. Any object that's falling to the ground, it's falling because gravity is pulling it down. That's gravitational. Now, if I pull this ball up and hold it here, it's now got gravitational potential energy acting upon it. But that gravitational potential energy is just being held there, isn't it? It's not moving. That's what we mean by potential energy. When we looked at the matches, these are stores of chemical energy. It takes energy to kind of get them to start transferring that energy. So we could say that a match is a store of chemical potential energy. Now, this ball, which has gravitational energy acting upon it, when I release it, the gravitational energy store reduces, but the kinetic energy increases. So gravitational and kinetic are linked. As this speeds up, graviton gets closer to the ground. The gravity is reducing, but it's speeding up, so kinetic is increasing. So with gravitational, we could say like a skier at top of hill that's moving. Elastic, that's just a stretched elastic band, isn't it? Elastic band. Now, remember that it doesn't have to be an elastic band. You know, it doesn't have to be stretchy. If this ball, if I squeeze this, this is still elastic. It's just in compression rather than in torsion, rather than being stretched. And then our last ones, we've got nuclear. So this would be the sun. The sun is nuclear energy, just like we described at the beginning of the video. Electrostatic. If you've ever been on a trampoline and found that your hair all stands on end, that's because you're building up similar charges on your hair, negative charges, and they're repelling each other. So opposite charges would be electrostatic, or two opposite charges. And then electromagnetic. Electromagnetic is just the kind of force field that exists between magnets. If you have two magnets, north and south, we could have south and north there. That repulsive force here, the repulsive force that exists there is the electromagnetic force. So we'll just say poles of two magnets. So they are all the main energy stores that you need to know about. And now we just need to talk briefly about the four ways in which energy can be transferred. One of the first ones is mechanical. You know, if we think of a skier at the top of a ski slope coming down the slope, we've got gravity acting on that person at the top. As they come down and speed up, gravity is pulling them down. Their gravitational energy store is decreasing. The kinetic energy store is increasing. So gravity is doing work on the person, kind of mechanical work. We'd say these forces are actually forces acting at a distance. They're not actually contact forces. Gravity acts on an object, whether it's touching Earth or not. It could be kind of up in the air here somewhere, but it's still acting upon it. Energy can also be transferred electrically. You know, when you plug in a device or you plug in your mobile phone, you see on the screen that it's kind of charging up. But what's actually happening? Well, what's happening is that electrons are flowing through the circuit and are doing work on the battery. They're kind of colliding and transferring energy. And every time they collide, more energy is transferred to the phone battery. That is kind of energy transfer through electricity or electrical energy. Energy can also be transferred through heating. Now, a lot of things in science kind of rely on this same kind of concept, same with diffusion and osmosis, for example. But when we're talking about heating, if there's a temperature difference and one object is quite cool and the other is quite hot, there's a natural tendency for the hot object to kind of lose its energy and the cool object to gain energy until they reach equilibrium. That's a transfer of energy through heating. Now, energy can also be transferred through radiation. And an example of that is light. Light is transmitted across a room. When you plug in a light bulb, it lights up and the energy is transmitted through the room. We say that the light's kind of radiating from the source. That's radiation energy. So that's everything you need to know. This lesson covers AQA and Edexcel and OCR. There's no kind of real variation between any of them. So I hope that helped. If it did help, then like and subscribe. Thank you very much.